So yeah, let's jump into it because we have only 1 hour. This is me. I was just introduced. I can skip this. Yes, I have a blog. I have coding guidelines for the last 20 years. I have an event sourcing related project that is kind of feature complete, and of course fluent assertions. Oh yeah, and there's chill. So I'm pretty active in the open source community. So let us jump right into the material, a modeling exercise, because this is what we usually, you start normally as an architect with a business case. I have a business case, and the business case is I have a mortgage application. And if you have actually bought a house, and I assume it is just as complicated in Romania than it is in the Netherlands, you typically need to provide a lot of documents, proof that the salary that you've been saying that you have actually exists, that you don't have any, I don't know, outstanding debt somewhere that's going to affect your ability to pay your mortgage. So you need proof for that. And there's a lot. I mean, I've bought, I have only one house, but I've actually bought 3 or 4 houses in my life, and it's always very painful, a very cumbersome process. So you need these proofing documents. And obviously, there's usually a third party, which we call a signing loan officer. That's the person, a man or lady, that will check all your documents, make sure everything is complete, everything is signed off before it goes to the mortgage provider and allow you to actually get that money. Because yeah, it's not 10 euros, it's usually, I don't know what's the market in Romania, but a decent apartment in the Netherlands, it's at least 250,000 euros these days. Unless you live in Amsterdam, and it's probably 2.5 million. Anyway, so you have these 3 concepts. Now the question is, how would you model that? That's the question, and I can't really make it interactively, so I did a kind of proposal. I don't know if you actually see all these pop-ups in my screen. I hope not. This is a way of modeling it. You know, I have a mortgage application with 2 properties, a number that identifies the mortgage application, the version for optimistic concurrency, which points to 1 or more legal documents. And by the way, this is UML, and I see at least one person with gray hair, so they probably remember what UML is. I hope the younger generation is still using it. This is what we call a class diagram. Yes. Thank you, Eduard. I can see you smiling. That's good. We have a legal document, and that legal document has a connection to 0 or more signatures. And those signatures are obviously signed by a loan officer. Makes sense, right? I mean, that's a pretty logical domain that you would create. There's a couple of things. I have been very particular about the terminology. The legal document is the terminology that the business behind this, the whole, let's say the mortgage application business or the financial industry, that's a term they use, at least I think, because I didn't have a product owner available to talk about that. A mortgage application is the name that you see here. Where's my mouse? Here. You can see it here, the signature and a loan officer. Just check, can you actually see my mouse? Moving? Good, thank you. See, that's why I want to be able to see people. And it's signed by the loan officer. Using the terminology of the business is very important. That's what ubiquitous language is about. It's also very important to explain that to the people because they may have different terminology, and that's very important. The terminology is specific to a particular domain. So if you're building a complicated system with multiple domains, you will also quite often find multiple ubiquitous languages. It's also important that if the terminology changes, because they have a breakthrough, they determine like, yeah, it's actually not a legal document. We just call it a document. Then you should actually change your domain, but also your code, your unit test, everything. That's what ubiquitous language actually means. You also see an aggregate root. And what's specific about this is what we call an entity. Aggregate root is basically the thing, the entity that provides the entry into a bunch of entities that live together. We'll revisit this topic in a later set of slides. But a mortgage application has an identity. You can refer to the application by its ID or number, whichever it means. Whereas a signature, you don't actually say it was this signature. The signature is usually just a combination of maybe the person that signed it, maybe a sequence that says something about an order, the date that the signature was set, And to identify that signature, you refer to the combination of properties. So in this case, it's a value object. That's why we use it. So you can compare two signatures by comparing their properties. The good thing is that these things don't change, they're mutable. That's at least the convention. So you implement value equality by comparing properties. And the loan officer in this case is also a person which can be identified, which makes it very easy, right? So it's a simple model. And that's probably also the model that you would implement if you would do the same thing. Now, you cannot really model something without understanding the business rules. That's what I'm going to show you now. Because, yeah, I mean, this is a logical, more like an entity relational kind of approach that most people take. So let's say, oh, and by the way, I forgot about that, of course. This is something that we usually call bounded context, which is a fancy word for saying these things live in a domain. The language within this domain is legal document, mortgage application. So the ubiquitous language in this domain is kind of tied to the bounded context. And the reason why I'm saying it that the same thing, the mortgage application, may have a different set of properties in a different domain, because this is about filing an application or applying for a mortgage, but maybe in a financial system which is somewhere else, we choose to use have another entity with the same name with different properties. That's why I'm saying we have a different bounded context using a different terminology, different term for the same thing, and it may even have different properties because the goal is different. That's very important. So let's assume that the mortgage application cannot be accepted until all proving documents have been signed off. How will we implement that? Well, there's plenty of ways of doing that. For example, I could use the database. I mean, in a traditional system, and you use a relational database, you have concepts like a foreign key. So in this case, I've introduced, let's say, almost like a table called proof. And the proof points to a signature. And the loan officer will mark the actual proof. In this case, the proof represents the combination of a legal document, the signature, and the person that signed it. Will be marked at some point as verified. So how do we prevent then somebody from removing the signature? That's very easy. We use a foreign key constraint. That's how we use it to do it 20 years ago. We use foreign key constraint for everything. I mean, as soon as the foreign key constraint is created to this signature, it's not possible to remove the signature anymore because the database will prevent you from that. Yes, but then you will tell me like, yeah, but you know what? It's a database. People can actually interact with the database at the same time, right? So in that case, we say, yeah, but you know what? We'll use a transaction to guarantee that these changes are not touched by other people at the same time. That's a way of implementing it. And that's perfectly okay. Perfectly okay. Make sense? Yeah. But you can also solve it differently. Maybe you don't want to use the database. Maybe you use a NoSQL solution which doesn't have transactional boundaries or doesn't understand foreign keys. Maybe we can actually solve it functionally. How? Well, by just not exposing a method on the legal document to remove a signature. Also perfectly okay. Depends on the context, of course. Depends on the particular system that you're building. But this is perfectly okay. If there's no way, I mean, why would you have to protect somebody from accessing your database? Maybe not. Maybe your database is running in the cloud and it's completely hidden. There's no way anybody can access that database directly, and we don't have to make it more complicated. That's one way. But if you practice domain-driven design, a lot of people are used to try to model the invariance in the domain. And that's what we can do if we do it like this. And now it becomes a different story. It still looks the same. There's still a proof thing. It has now direction. It has kind of references to a legal document and a loan officer. And in this case, what we're saying is that, you know what? We make this proof entity part of an aggregate. And we have an aggregate. It protects the signatures. We have an aggregate boundary. What you may notice if you know a little bit of UML, that there's a little dash in front of proof. This means it's actually internal. It's part of this aggregate boundary. And what we're saying is you cannot actually touch this entity, this proof entity, outside the mortgage application. So we have an aggregate which consists of two entities, mortgage application and proof. This is the aggregate root. So this one has properties and methods which are accessible from the outside of this class. But the proof it isn't. So the only way to add proof or remove proof or sign proof is through the methods of the aggregate root. And we use versions in this case. I think there's even a balloon saying they use versions for optimistic concurrency. So whenever somebody adds proof, removes proof, or signs proof, it will bump the version of this entity stored in a database, which means if somebody else tries to do that, do the same thing at the same time, because yeah, we have a concurrent system, it's not possible to do that because the version will be different than the one that you try to apply the signature to, and you get a message saying, yeah, this mortgage application was changed by somebody else at the same time. That's the whole point here. So you model your entities, your aggregate roots, to protect the invariance. And there's a very nice article. It's written by Vaughan Vernal. It's called, I think it's called Effective Aggregate Design. There's also a book, by the way, written by him, but there's 3 PDFs that you can easily find. I think it's at the end of my slide deck. If not, I will add it. That try to explain this a bit better. Because I used to think by, we have this concept in the domain, a client is talking about a mortgage application, which by definition means I will have a mortgage application entity in my domain. And that doesn't necessarily have to be the case. You need to model your domain to protect the invariance. More people are joining, I see. Now, that's one way of doing it. Now, how does that translate into architecture? Because we didn't talk about event sourcing or CQRS or any of that. But we will. And maybe, I don't know if you already get the signal or the little message I'm sending you is that there's not a single solution to solve everything. If somebody tells you, no, you need to use event sourcing. No. Or you need to use domain-driven design. No. It's just a way, we have this let's say, mental backpack on our shoulder, this backpack with all this knowledge and information that we learn. We have people like me that try to, preach to you what's the way to do this. No, it's just tools. So let's look at the architecture. And we don't look at an architecture without constraints. You cannot just design an architecture without understanding the business rules. So we have one. And it says, given the fact that reading should be fast, and I've been asking questions, collaboration is low, which means in normal circumstances, you will not have a lot of people trying to change or apply or add proof to a mortgage application. And that's normally true, right? You as a person that wants to buy a house, that's usually you and your partner. And then thank you for the link. Indeed, that's the one, Eduard. Usually there's a company that does the mortgage application. There's usually one person that does that. It verifies all the documents. So the number of people that try to change the same kind of data is very low. But reading is important because probably there's a lot of people that are interested in seeing what are the open mortgage applications, because the bank probably wants to understand how much money they're going to earn from all the applications. So we're saying reading should be fast, collaboration is low. So how does that translate to an architecture? Well, I can imagine many things, but maybe a simple CRUD architecture like we've been doing for the last 20, 30 years is perfectly okay. Maybe we don't need more. We have a web app, and of course it's all single page applications because that's hip. We use React, or maybe that's even old fashioned. Now we use Swelby or Vue.js or whatever is the next fancy thing. We have an HTTP API, domain. Maybe we even, I know that people will shout at me, use an object relational mapper like an Hibernate or Entity Framework. It's not a bad thing per se. There will be people in my community that say, ORM, object relational mappers, that's something from the past. We don't do that anymore. I would say, and this is recorded, bullshit. No, every tool has pros and cons. Understanding when that tool makes sense and when it doesn't is crucial. There's not a single tool that will solve all your problems. So I'm saying, if you have constraints, like you need to use a relational database, maybe like SQL Server or something, then perfectly fine. This is a good architecture. There's no requirement on the table that I told you that warrants anything more complicated. But we can make it more complicated. Maybe we prefer to use a NoSQL solution. You're on Azure and you want to use, what is it called, Azure Cosmos DB. Maybe you prefer to use MongoDB because it's very convenient and flexible. If you're on Amazon, you may want to use Aurora or Postgres, which also has NoSQL capabilities. Then maybe this works. So you know NoSQL database with your documents, your proofing documents, everything is here, your signatures. You use your domain to protect your invariants, and you have indexes or maybe even Elasticsearch if you really need that power. All depends on your requirements. It's also a perfectly nice solution. Maybe you feel very uncomfortable with these simple architectures and you want to acknowledge the fact that we have a domain which is optimized for protecting the invariants, and you have a more like, let's say, query side which is optimized for queries, which you see here. So you can kind of separate those two worlds. You have the command side, you can see commands, and they usually use the ubiquitous language. And you have your command handlers, which try to capture more complicated business rules, not just a mortgage application cannot be approved unless the signature has been set, but maybe more complicated things, because you have some workflow behind that. You capture that in your command handlers. Your domain contains the aggregates, the entities that we talked about. You use a NoSQL database, but querying happens through a different channel. What is this architecture called? Command, query, segregation, principal. No. Command, query, responsibility, segregation. CQRS. See, it's Saturday afternoon for me as well. I had 2 handball games I had to coach, so that's why my voice. Anyway, so acknowledging that difference is quite okay. I think kind of it's become my default architecture, which doesn't mean I will always apply it, but it's my starting point. Because I know if the system becomes sufficiently complicated, usually the reading and the writing, these two concerns start to create friction, and separating them is not that expensive. It doesn't require you to change the entire architecture, because under the hood, I will typically use a NoSQL database because they're much easier to use in the cloud these days and cheaper to use, by the way. So yes, CQRS will help you here, but it's not a requirement. It's just a tool, nothing more than that. And we have options. So let's move on. Maybe we can actually use additional requirements to make our story more interesting. And somebody told me, yes, but this is a financial system. We're talking about mortgages. We need to be auditing that. The loan officer is being audited by a third party that they do everything the correct way. Did they actually properly sign off all the documents? That kind of stuff. Did they not actually accept some fees under the table for the job they're doing? Well, you can probably check that because, yeah, you do it under the table, which means you physically give money. But you have a requirement. So now what? Oh, then, the fancy architect will say, oh, event sourcing, because then everything is completely, auditable. No, because there's plenty of ways of solving that. I mean, how difficult is to build an audit trail? Most NoSQL solution, I know MongoDB has it, Couchbase has it, even RavenDB in the .NET community has it. There's an audit trail there. It already has like a change log that you can use. That is your audit trail. It doesn't look very readable. It's not functional or something like that, but it does show you all the change that happened. Perfectly sound solution, I would say. I don't need anything more than that. Wow, people come in very late. So that's a solution. Other solutions? Sorry, that's actually correct. Yes. Now we have a new requirement. And by the way, what I just showed you, this one, you can also implement it on a SQL database, because even Oracle or SQL Server have some form of audit trailing, but you can also build a separate table. It's not a big deal. I'm pretty sure SQL Server has some mechanism to produce an audit trail as well. I've never done it myself, so you can look that up. But we need another requirement. And the other requirement is actually, we looked back and we had some discussions with product owners, and then we were talking with the banks, and it turns out that it's actually more than just a few people that I mentioned at the beginning that work on the same document. So we actually need something, we need to be prepared for a lot of people because the system was running in production for a while, and we discovered that we ran into this optimistic concurrence exception quite often. So we need a different architecture now. So we have a new fact. It's not a requirement, it's just a fact. Many people work on the same documents concurrently, and optimistic concurrency is no longer an acceptable solution. All right, what can we do about it? Should we use event sourcing? Good question. So let's see. We have an app that sends commands. The commands are processed by Command API. It's of course HTTP based because that's what we do these days. I don't even want to use the term REST because it's so overloaded. You can have completely religious debates about that. Don't want to do that. Command handlers. What happens then? We produce events. So instead of writing a proofing document or the proof itself or the signature or all this information directly into a table called mortgage applications, or what's the plural of proof? Yeah, it's actually proof, but yeah, that's annoying. We actually store events. So we capture, and by the way, they're written in the Ubiquitous language. We capture what happened in that domain. We kept the fact that somebody actually issued some document for proofing, or some document as a piece of proof that this person is financially capable of handling the mortgage fee for every month. We also captured that the signature was set by a particular person. We captured that the loan officer left the company and another person had to reissue the signature. We captured that the proofing document was rejected because something was missing, or it turns out that the pay slip that the mortgage applicant, the person that tried to buy the house, was all dated, was too old, and issued another one. All of this can be captured. That's very nice. So you don't just capture that the mortgage application has a new signature, you also capture like a specific element, because these commands are written in the Ubiquitous language, of course. Also the events themselves. And that's very powerful. The advantage of this model is not just the audit trail, but it's really great for unit testing. You can actually create unit tests, and if you do .NET development, it's very easy because you can actually build an in-memory network pipeline where you send an HTTP request, like I'm signing the proof, and then verify that on the other end, on the pipeline, here events are stored of the right type, and no other events are issued. You can verify that. That's very nice to do that. I do that all the time. So this is a very nice unit, and I don't want to start a debate whether this is actually a unit as unit testing. It's just a very nice boundary. You can test smaller if you want to. I actually choose to test at this scope. One extra advantage, you can replay old data, the old events that happened in the past, against a new domain, and maybe even reapply certain business rules. You can do that. You can also analyze the data in a certain way. You can do data mining on that. One caveat is that you need to understand your domain really carefully, very thoroughly. I made it oranges because I don't think it's necessarily a negative thing, because understanding your domain is actually a good thing. It's just that previous types of architecture don't force you to think so hard, because you really have to think about what event is actually a functional conflict with another event so that we can merge them. Is changing the address of the person that issued the mortgage a conflict if the what do you say, that the price of the house didn't change? Probably not. But in a traditional system, you're updating the same entity, that would be a conflict. Here you can think about these and have sensible discussions with your product owner to understand, is this really a conflict or is this totally okay? That's possible. So that's why it's orange. If you've done event storming and you've attended some of the presentations, really aligns that with well. I mean, event storming is a brilliant way to design the events, to think about the industry or the domain, the business domain, by thinking about the things that happened. You know, somebody issues a mortgage, somebody signs a document, it gets verified, because that's how it works. You can talk about the process. That works really well. There's a question from Mike, by the way. Do you suggest to unit test the commands only? No, the commands are just messages. So what I'm saying is I test the whole thing. I'm issuing a command as an HTTP request, and at the bottom, I'm verifying if the right events were produced by the domain. That's the level. Hopefully it answers the question. As I said, you can replay, but you can also look at the state. You can actually say, I'm going to rebuild the domain until a particular point in time to see what was the state of that mortgage application at that particular time. That's very powerful, especially for complicated systems. And obviously, you get auditability for free. Yes. Because aggregates are now loosely coupled, they cannot actually refer to each other like with ORMs. You can just create a property that dynamically loads the other entity. That's not possible anymore. You need to refer to individual entities by IDs or functional keys, which makes it a little bit more difficult, and I would say just a little bit, to understand the relationships between all the aggregates. That is something to take into account. Now, we have the querying side, completely optimized for querying, because they receive events and they use projectors to produce those events in any way what you want. This side is completely optimized. And again, great for unit testing, because you can actually say, hey, you know what? I'm producing in my unit test a stream of business events, and then I do an HTTP request and verify that this actually happens. If you're interested in this topic, by the way, reach out to me. I have some code example on GitHub showing how you can build tests like these in a very efficient way. You can even build your own little domain-specific language. It's part of my DDD presentation. So yes, we can, and it has lots of advantages. But as you learned by now, it's not really necessary to do that. You have options here. Yeah, lots of advantages. You can make these things completely autonomous, which means there's no direct transaction here. This happens in the background. So it means it scales almost infinitely. Yeah, that's actually it. Yeah, of course, no relational table. But that's actually an advantage in this particular case. By the way, if you used to use your query database or your relational database as a reporting tool, yeah, that will affect it. You have to rethink that. What we actually do is we have internal projections, so specifically designed for the particular screens in our application. And then we build a separate set of projections specifically to be a source for data mining. Because, yeah, you can build multiple projections and you can even build them asynchronously, so they don't affect the performance of the system. All right. But, again, it's a tool. So does it mean it applies to the entire system? I mean, I showed you a CRUD-based solution, something using Elasticsearch. It's all valid. But if you choose event sourcing because of the requirements I just showed you, does it mean that you should use it for the entire system? Well, the fact that I asked you this question probably alludes already to what's coming. No, because every domain has different requirements. That's why we have bounded contexts in domain-driven design, and every bounded context has different requirements. So maybe we have a domain where you draft your mortgage application. Do you care about an audit trail for drafting? Probably not. You know, you're just collecting information as much as possible, and that's it. Maybe you have a policy execution domain. This is where we actually have to ensure that the policy, that the mortgage application follows the rules, the policy that apply to the mortgage application or the mortgage industry. And maybe you have a separate domain which deals more about, you know, providing insight in the mortgages, in outstanding mortgage payments, in the houses that are being sold and all the combinations, which is maybe needs a completely different, is governed by different requirements. You know, drafting is something you do alone. So maybe this simple model that I showed you at the beginning is perfectly okay. Just NoSQL database, a simple CRUD-based architecture. Completely okay. Here, you need more things. Maybe here is where event sourcing can be used as CQRS, but everywhere else, you may not need that. And searching, yeah, of course we use Lucene or Elasticsearch. That's what it's designed for. So how do they communicate? I don't know. Maybe a bus, something that nobody seems to be using anymore. They are in the cloud, they're available, both Amazon and Azure have them. And your policy execution just subscribes to your drafting domain, and your drafting domain publishes coarse-grained events. Have nothing to do with event sourcing. It's just event-driven. Yeah, whenever a mortgage application is marked as complete, all the details are filled in, only then you publish this to a bus, which means this execution domain is actually going to be started. Before that, we don't care about all of this. And maybe this part uses webhooks because the search domain is running somewhere else and uses coarse-grained HTTP requests to get the information back. That's perfectly fine. There's a complicated question which I cannot answer right now from Christian. Maybe we have time at the end. So it makes sense, I hope. Different styles, different architecture principles apply to different domains based on the functional and non-functional requirements. That's really important. Now, let's look at querying. How much time do I have, Andrea? Can I still continue? Okay. Let's assume that we want to have a list of proofing documents, all the proofing documents with the state, the mortgage number, and the last loan offer that signed it. Not the first, only the last one. How would we build that? Well, we can do it like that. We already assumed that we use event sourcing, and we can actually have two projectors. One that, keeps a table with loan officers, one that keeps a table of mortgage proofs. That's what we do. And then we have two tables, which looks like the way we do it in the past. And we just join them during querying. That's one way of doing it. It's not very efficient, but very simple. Especially if you don't want to have too many tables, because you're afraid that your query database, whatever that is, by the way, can be an RDMS, can be something else. But you can do that. You can also say, no, I'm actually building a specific projector that is designed to give this answer in as efficient as possible. So it listens to events from actually multiple aggregates, because it listens to the mortgage, the loan officer, the signatures, all of them, and just builds one table in this thing in here that is specifically optimized and gives you this information directly. So whenever a new signature is added, it will just update that one row for that proofing document with the last signature, because the rest we don't care about, which is much faster because the read time will be optimized. We don't have to join tables. We don't have to join a filter. We just get one record from that table. Done. That's a way of doing it. And you can make it autonomous again, which means it can be asynchronous, for example, because maybe this app doesn't have to be very, maybe it's not that important that at the moment that you don't see the domain here, where the signature set that the UI is updated immediately. Maybe you don't care because it's different people that ask this information. Then making this asynchronous is very convenient because it makes your system much faster. And autonomous means can be asynchronous. I already explained this. Yeah. And as I said, can be anything. And as I explained, can be stale. Who cares? Maybe it's not an issue. And again, depends on the requirements. And that's, I keep coming back to that. Everything depends on the requirements, both the functional and non-functional. I keep repeating myself. Some more examples. What or if the new version of your code base requires a schema change? Your projection is stored in a SQL database, and we have to actually add a new table. How would we handle that? There's different ways of doing that. We can do an out-of-place blue-green update. We have version 1, which obviously has projectors and event store. Then we deploy version 2 side by side. And then we ensure that version 2 returns a 503. That is a load balancer, so all the traffic is automatically redirected to version 1. Version 2 is not reachable, so your load balancer will not send any traffic there. Then what happens is we copy over all the events from the old one to the new one, because that's your history. That's everything that ever happened in that system. And then we project that into a new structure, in a new schema, in the background, while this system is still running. Version 1 is still actively processing request from the clients, from the end users. When this is done, we bring, and we can even automate that. That's what we do. We automate bringing the old system offline. Usually it means we make it read-only. So people can still access the data. They just cannot issue new mortgage applications or set new signatures, but they can still access the data, which makes it very convenient. And if you do this in a very smart way, this can happen only in a fraction of a second, because you just keep copying over the data. And when you bring it offline, it's only like a couple of minutes, maybe even a couple of seconds, where this system is not available. Then the system will return 503. This one will no longer return 503, and the traffic gets redirected automatically. That's very nice. That's a side effect of using event sourcing. You can also do in place, which is easier to build. But then the problem is version 2 is actually here. So you have to actually stop the old system, build a new one before you can actually use it. You can do maybe some smart things by building a new table side by side, but that's effectively what we just showed you before, but just on a smaller scale. That's possible. But it means downtime. And that's typically something you don't want. And there's as I said, you can already see that there's already there's a scale between fully blue-green, fully in place, but you can even maybe look at each project, especially if you deploy in the cloud, you have a completely automatic deployment pipeline. You can apply these strategies at a much smaller scale. But there's plenty of ways of doing that. Now, what if the terminology changes? Because I talked at the beginning about the ubiquitous language. What if it turns out that the domain changes? The PO discovered that the terminology is different, should be used differently. We have to do event conversion. How do we do that? We have a command, some command and a send the event. For example, it gets a customer with identity 123, which produces an event customer created. It was one of the first that came in, because that's what you get from the event store. Now we have something called event converter that runs at runtime, processes that events, and can do lots of things. It may decide to split the event into two, or maybe merge it, because the current code base only understands the new events. So that's either the merged or the split event, and it doesn't really understand the old ones anymore. I mean, it can still read it, because it's in the event store. And if your system runs sufficiently for a couple of years, you will have lots of old events in that event store that you no longer want to support, but you still need to be able to read it so your converter can process them. It may also run this as part of your migration. For example, I just showed you this, out of place blue-green deployment. You can also run this whole process during the migration, which means the new code base does not have to deal with the old events at all anymore. That's a choice, by the way, because if you do this during the migration, you're effectively changing history. And if there's a bug in this process, which happens, we have experienced that the bug in the actual conversion process, you may not be able to reach out to the old information anymore, which is a problem. It may even change the identities. We had some situation in the past, and maybe you heard me talk about it on a different presentation, where the identity was a username until we discovered that username is not actually the identity. It can change over time. So you need to somehow map this old username maybe to a GUID or something else. That's what a converter does. In this case, it produces a new event with the exact same data. It's just that, we talked with POs and they said, we don't create a customer. I mean, marketing people like to think they create customers for their market, but they actually enroll a customer in their system. So we would like to know this. And again, this is what you should be doing, because you want to keep your domain in sync with your ubiquitous language, but it may not be worth the investment. It's up to you to decide. But then this event is used to reinitialize the customer entity. Then the rest of the events which are not affected by the converter are loaded into the customer, and then the rest happens as usual. That's one way of doing it. What if there's a bug in a projection? That's another scenario. Or rebuilding this projection is just damn slow. That's possible. Especially if you have a big system with lots of events, it may just take too much time. And you may apply this blue-green concept, which means there's no downtime. But it still means, I've experienced that, that the ops people want to stay, they are still monitoring this process, and they may actually reserve time during the weekend to do that. So you want to make it faster. Well, then just build fast projectors. That's the answer. I once knew an architect that said, your architecture is just too complicated. I said, well, okay, I see that as well. My architecture is very complicated. So how do you make it simpler? How do you recommend I do that? He said, yeah, you make it simpler. I said, oh, okay. Yeah, that will solve all my problems, of course. No. So yeah, build fast autonomous projectors is a simple answer. It's not that simple to do. Or is it? Well, let's see. What can you do? I have an event store. I have lots of different projectors. I have one that uses a relational database. I have one that uses a document DB or a NoSQL solution. This one is autonomous and independent. It just subscribes. So the answer is actually make all your projectors autonomous and independent, which means they track themselves how much they have projected, because it allows you to actually optimize your storage technique for that particular projector, especially if the data is not actually needed all the time. It doesn't have to be completely consistent with the domain. And you may choose to use raw SQL. That's perfectly okay. You might actually want to use RavenDB, because RavenDB and MongoDB also has all kinds of fancy features like batch execution, caching, that you can use to make those projectors really fast. You may even use an ORM. And people would say, but you don't have to solve the object relational mismatch here. No, you don't. But an Hibernate has very fancy features like batches, query caches, and stuff like that, that make it very fast, like especially if you have to update different columns of the same row, not at the same time, but because there's a lot of events trying to update the same row. Using an Hibernate makes it actually faster than using raw SQL. And I've written lots of articles about that on my blog. If you're interested, reach out to me. Your caching strategy, because it's autonomous and you don't have to assume that all these projectors are processing the same events, you can use a completely different caching strategy. In fact, you may even say that during rebuilding, where nobody is updating the event store at the same time, you may take a completely different strategy. For example, doing stream-by-stream projections. So instead of processing the entire event store in order of the events, you first take all the events of the same mortgage application, read them throughout the entire event store, and only write the final result into the event in the projection. That's a very nice way to optimize it. Again, options. And if you want to understand the details, reach out to me. I can help you with that. What if we have 4 years of data and rebuilding is still too slow? So we did all the fancy stuff, and yeah, I mean, it's still too slow. You can do something like archiving, and I'll quickly show you that. We have a graph projector, and a projector, again, is just a thing that listens to the events and produces something that's useful. In this case, we built a projector that tracks all the dependencies between the documents, listens to the event store, receives an event, document 1 is created. Other events happened, obviously, over those 4 years. Then a document is closed. What happens? The graph projector knows that. And it actually tells the document itself, you need to archive yourself. What does that mean? Well, first by saying, you know, I'm a domain, I'm an entity, we use event sourcing. I'm going to mark myself as I'm going to be archivable as of now. Okay? That's stored in the event store. So you can track that. You can actually see back in the history of the event store that it was archived. Then we have a projector that only listens to active projections. It decides that, hey, you know what? I just learned this document is no longer used. It's closed. It's now actually being archived. I'm removing the projections, which means if you use a SQL database, that the number of rows will be kept to only the active documents, which means querying is still fast, because even if you throw a couple of clustered and non-clustered indexes, while you can only have one clustered, it can still become slow. So what do? You reduce the subset of data that needs to be available. Then you build a special archiving projector that listens to only that event. What does it do? It actually updates the event store to mark the events as archived. What happens then? The next time this projector needs to project the data, it can actually look at metadata of those events and say, I don't care about it. It's archived. I don't even have to project it anymore. Even if you do this blue-green thing, when you're building a new database, it's archived. I don't care. It's a very nice solution. Or you can even delete old events. It's a much more. You actually take a snapshot of a document and then store that in the scene index and just tombstone the actual event. So you delete them from the event store because you don't care about the history anymore. You only care about a snapshot of that document for past reasons. Maybe you store a PDF of it in Amazon S3 or Azure Blob Storage, and the rest of the system doesn't care about it anymore. Perfectly okay. Perfectly okay. I think we still have about 5 minutes for questions. I think, yeah, there's some additional stuff about tombstoning streams, and it's a lot of details that you can build to make it traceable. And then you can search on 2 different places. Yeah, what if you need to capture the original name of a loan officer instead of the one that was doing signing? Adrian, you want to say something?
No, sorry.
Okay. No. Yeah, then you can store the name and event. That's easy. You just store the name of another entity, and that's maybe think about it. So when the signature set, you just don't store an ID of the loan officer, but you actually store the full name of the officer in that signature. That's okay. You can also solve it in different ways by rebuilding this from scratch or by building a separate projection that listens to the versions of the name changes of the loan officer. You can do that. But storing an event is also okay. Then you can see both the original name, especially when people leave the company, decide to tombstone some of the data in the past, then you can do that. These are very advanced scenarios. I don't expect everybody to remember this by heart. There's plenty of material on the internet about that, and as I said, you can ask questions about that. Lookups is one other example where you actually build a specific lookup that keeps track of all the names of the loan officer inside the projector that deals with the mortgage application. That's totally fine. Or even enrich them during projection. That's another way. So you build an actual persistent lookup, so a separate little projection that keeps track of all the names of the loan officers. So when you start projecting them, you actually have something that updates an event on the fly. Hey, you load an event from the event store. It goes through the modifier that looks up, and this is probably cached really heavily, the name of the loan officer and project it there. So you don't have to do queries across projections because you shouldn't be doing that, especially because they're autonomous, which means every projector might be in a different state at that particular time. Yeah. Now, what if you run into something that I didn't cover up to now? Yeah, that's easy. Then you just ping me. That's the whole point. Yeah, I mean, there's so many scenarios, and I'm really troubled about the number of articles and presentations on the internet that just say, this is the way you need to do it. That's not how it works. There's so many options, so many, ways of solving the same problems in different ways. I mean, you know that you're software development. There's no one way of doing it. I just tried to give you in this small presentation some options, and also showed you a little bit like how CQRS and event sourcing can help you solve certain business problems, and that's what's really important. The functional and the non-functional people. Sorry, I see people in the room. Sorry, the functional and non-functional requirements should dictate what you build. Technology is never a driver. At least it shouldn't be. And I hope you agree with me. So yeah, if you run into more questions, then ping me or email me, whatever you want. Which I think brings me to, any questions? Somebody's saying I'm trying or pretending. That's funny. Yes, I'm also pretending to do event sourcing. Actor models, yeah. Actor models and event source. I actually know, answering Christian's question, there is an open source headless CMS called SquidX that uses event sourcing and an actor model. but they mostly use the actor model to implement the domain side of the story. So if I would go back to the slide with the domain model in it, for example, this one, what they do is, use an actor model to process the incoming requests. So the incoming HTTP request is processed, and then an actor is, it's called Grain, I think, in Orleans. They produce a message, and that message internally handled by Grain, which then updates the domain, and eventually the Grain is used to update the event store. So it's possible to do it. It will make you a very, very extremely scalable solution, but it's mostly a solution on the command side, not on the query side. So hopefully it answers your question. Any other questions?
There's two more above that. The one you mentioned was a bit complicated for the session, maybe it's too much, but the second one, maybe it's a bit shorter.
The event-driven architecture, the complex event processing, it's a question I don't understand the question. So maybe we should discuss that offline. The other question from Christian, do you correlate events to application logs in case of a runtime issue? Or is there actually, we use events, we don't store them in a log. We actually use the event store for diagnostic purposes. So the system I've been working on the last couple of years delivers a product which is deployed to an actual client on-premise, for example, on a ship, an oil platform or ship. And we've asked sometimes to receive, when there's a production issue, just a copy of the event store, not the actual projection, just the event store. Or even a subset of that, like give us a copy, all the JSON of a particular period of time in that event store, and then we can actually trace back exactly with that version of the code base what happens. We could even replay that particular scenario and see what happens and put a debugger on that. That's extremely valuable because without event sourcing, you obviously don't have the history. Because an audit trail, yeah, it can show you some information, but you don't really see what happened on the domain side. And being able to replay that was very useful for us. Storing up in the log is kind of duplicating the data because your event store is the log, right? Hopefully that answers the question. Any other questions left? Awesome. Well, I mean, I'll share the slides. If anything pops up, don't hesitate to reach out to me. That's completely okay. Hope you enjoyed it. Hope it was not too deep. There was a lot of content in less than an hour, so I did my best. And I couldn't really see you guys, so it was difficult to judge whether if it made sense. But yeah, hope you enjoyed it.